Hello everyone. Welcome back to Kredict. This is 45-day challenge in which we are learning blockchain development from smart contracts to decentralized applications. And today is day 20 of this challenge. In all the previous videos, we have learned about Solidity smart contracts, their features, functionalities, and all kind of cool stuff we got in Solidity. So today we are going to learn and implement our first smart contract in which we are creating a smart contract for, you can say, election or the voting procedure. We are going to create a smart contract based voting system in Solidity. So I hope you are excited. So without wasting any time, let's get started. For this, just open up your browser and we can say the remix ID we are using throughout this series to writing our smart contracts. And if you're following along this series, you also have this blockchain tweet folder on your IDE. Just open this up, and here all are the smart contracts we have written so far. So I'm just gonna create a new file here. You can say create new file. I'm gonna name it as election contract or whatever you can say. Just I have created my file, and quickly I'm gonna create the boilerplate for this, and this will work on version 0.8.20 and all the later versions after this. So just write contract here and name election contract. So our basic body of contract is ready, and now we are going to write our smart contract for election. So before this, in general, we can see what are the procedure or steps we need to design in the smart contract. For this, we are just going to create two candidates, and each user with a valid address have right to vote any of those one candidate, and one user with one address cannot vote multiple times. Okay, and we have a function to count the votes for each candidate and a function which returns us the result who won the election. Okay, we are not going to reveal the actual number of votes for each candidate, we are just getting the result. Okay, and we can modify this according to our use, but for now we are keeping this thing in mind, and now we are going to start writing our smart contract. For clear view, I'm just gonna close this, increase the font size. Okay, so now I hope everything is clear to everyone. First of all, we need to count the votes for each candidate. So I'm going to create two candidate variables. You can say uint256 named as candidate A. Let's suppose our first candidate is candidate A, and similarly second one is candidate, you can say B. So here we have two variables, which is candidate A and candidate B. And now I'm going to also create a variable of string type which stores the text message, or you can say the message which signifies who won the election. So I'm going to say is string and result. Okay, and keep this thing in mind, we are not going to mention this public because we want to keep all these things private. And also we have to create a mapping for each user who have already voted. So it's gonna bool if he voted or not, and this also required to be private, and we can say voted. We will mark this true if any user vote their choice. Okay, so our basic variables is done. Now we are going to create our first function. First of all, I'm going to create a function for voting candidate A. We can do this by using same variable, I mean same function, but for simplicity, I'm going to create two functions for two candidate voting. Okay, so you can write function, write vote A. This function is used for voting A, public, and now here we check if the user has already voted or not. So you can say voted message.sender, and if this is not satisfied, we can say user already voted. So what is this doing? This is fetching the value from mapping, you can say voted, by using message.sender and checks for not, which means if this is true, then we won't proceed. So this value should be false because we are using this not operator here. Okay, so if we proceed, we can simply increment the candidate A by plus plus, or you can write this if you don't know, like candidate plus 1. This will work same, and now we mark the user as voted. So you can say true. So I hope this is all in vote A function. We are just going to copy this for voting B. Just name it as vote B. All thing will remain same. Just change this variable here, vote B plus 1. Okay. So now our basic functions for voting both of candidates is ready. Now we need to write some functions to get votes for each user or each candidate, you can say. So I'm going to write function get votes A. You can also mark those public, but we are going to see each of the steps by ourselves. So I'm going to write event 56, which return the candidate A votes. And similarly, another function which is used to get votes for B. This is also public view, and this returns U into 56 and return candidate B. So these are two functions which return the number of votes for each user. And now we have to create a function to count votes for both of them, or to compare, you can say counting votes. If you know how the election works, actually we first vote, then the election committee count all the votes and then declare the result. So we are creating this contract in the same order. We have votes, we have functions to get votes for each candidate, and now we are going to create a function like counting votes. You can say counting votes. And this is also a public function, but this will return nothing. This function just count and store the result in result variable. So if candidate A is greater than candidate B, the result should be, but we can say A won the election. Else result B won the election. But you can see in such a scenario when the number of votes are equal for both of the candidates, what we can do. So we can write this explicitly. We can write it as else if candidate B is greater than candidate A, and in else condition we will declare the result as tied. Okay, so this is our function for counting votes, and this will return nothing, just declaring the result, and we will create a function to get the result. We can also mark the public variable to result, but we are going to say result election, or you can say get election result. This is a public function also view, and this returns what we can say string, and which we are going to store in memory, and this will just return the result. Okay, so I hope our basic smart contract is ready now. Just zoom it out so you can see it in a full screen. Just drop this down. Okay, so I think our contract is pretty much fine. Just test this our implementation. Open this up and make sure that your contract is compiled and you don't want to compile it manually every time, just click on this checkbox auto compile and it will compile the smart contract with every change. Okay, just tap here, select your smart contract, click on deploy, and now here you can see we have 6 functions out of 3 are state changing and 3 are just, you can say, read variable or read from contract variables. In first, if you type get votes A, get votes B, it will be 0, get election result, this returns nothing because there is no voting done yet and counting votes is not proceeded. So if, for now, if we click on counting votes, just open this up to check any error. Okay, and now if you click on get result, you can see here it's tight because both of the votes are 0 and 0. So with this address, I'm gonna first vote for A. You can see the function has executed successfully. And if I'm gonna click on get votes A, you can see it's 1 and get votes B, it's 0. I have not changed the address, but still I'm going to click on vote B. So you can see it says user already voted. So I'm unable to vote anymore if I had already voted for someone. Now to vote another, I am going to choose another address and just click on vote B. Okay, not this, this vote B. Okay, so the function executed successfully and now I'm going to click on this. Now you can see both of the votes are same, and if we run on counting votes and get election result, it's still. So just let make the candidate A win this time. So click on vote A, and now the votes for A is 2. Switch back to our original address. Click on counting votes, get election result, and now here you can see A won the election. So I hope this is the most basic example of writing a voting smart contract, and this is the first application we have seen so far. So this how you can implement this, and to increase the privacy we can delete these functions to get the individual votes and just keep this, and you can also combine this, if we don't want to do this, just cut it from here, paste it here, and remove this view, and just remove this counting function completely. Okay, so now we have function, just format this quickly. Okay, so now we have function get election result, which counts and declare the result for us. So now we have one function less. Just remove this, redeploy, open this up. Okay, so now you can see we have only one function get election result, and if I click on this, okay, this return nothing. Why? Okay, okay. This return nothing because this is a state changing function and this does not return anything. So we can use events here. So I'm gonna create an event here, event election result, and this will take string result. Okay, so we have event here, and now instead of returning I'm just gonna emit, but we can say result. So I think we need to, okay, sorry, we have to write event name, this is result, election result actually. So just write election result and just remove this extra text. Okay, so now we are emitting the result, and instead of returning, just remove all this thing from here. So now we have our complete function. Just remove this previous one, redeploy, open this up, and now we have to keep track on events. Just clear this for now. Click on get election result and just open this up. And somewhere here you can see result is tied. But now if I vote on vote A and click on get election result, open this up, and now you can see A won the election. So there are multiple ways you can write this contract to implement this same thing. There are 100 ways you can do in whatever style you want. You can put extra validation, you can remove any function, you can add extra functionalities. This is all up to your implementation and how do you want to do this. So this is just a basic example of implementing a smart contract in Solidity. So this is our first application at day 20th, and now in further videos we are going to see more complex examples of implementing smart contracts and also creating some dApps. And in future we are going to connect the front end and back end. The back end in general is in Solidity. So we are going to learn all this stuff. So I suggest you to follow all this series along with us and get your hands on Solidity smart contracts and learn a lot about blockchain development. So I'll just quickly close this. So this is all for today from me. This is 45 challenge learn blockchain development by Kredict. I will see you in next video tomorrow. Till then, stay safe